All right, 7 o'clock. Let's get started. You can hear me, yeah? All right, I share my screen already. Okay, last week we started playing with either, but of course, the difficulty for start is that, how do we start solving problem? So for today, the lecture review, I will cast it like problem solving in general. The content of the lecture actually is the wishful thinking, which is a form of problem solving, a top-down approach. And also there is this discussion about how you should structure your code on good abstractions. And then introduction to recursion, which by now you should have learned quite a bit on trying out all the missions. Okay, so I wanted to do this problem solving in general. But as you would know from Chinese saying that there is always difficulty in starting something. All right, 万事起头难. This is a direct translations from when you want to do something, but it's always difficult to know where to start addressing the issue. Okay, today's review again will be like I will be doing most of the talking, and in a way, I'm trying my best in some form to show you how to solve problems. But the flip side of this is that I may spoil some of the fun in you discovering all these challenges yourself, because the sense of achievement by doing it yourself, it's much, much higher than you hear it from someone else. Okay, nevertheless, I think I should share with you what I have in mind. And then in three parts. The first part is on analysis. The second part is on actually doing it. And the third part is on all the toolkits that you can see, which is what we are doing in studying. Studying is to acquire certain skill and intelligence to then be able to solve new problems as we encounter them in the future. Okay, so this is the review that I wanted to share with you. All right, here I basically I already I've written everything, just that I will just show them bit by bit. Then you can. All right, given the problem, where to start, and that is the question that we always trying to answer. Uh, in actual fact, problem solving always come with experience also. Okay, so there is no fixed way to solve problems. Some people, as you will see yourself, it's a form of discovering yourself. Whether you are in this kind of top-down approach, bottom-up approach, or somewhere in the middle, the kind of differences among all of us, as I will point it out. Okay. All right. So what is problem solving? Actually, in our context here, but problem solving it's in a way managing complexity, because at your level, at in this course, there's nothing that, in some sense, that we give it to you, it must be solvable, right? Unlike some other higher level courses where they are unknown, even the professors themselves may have to learn whether this is solvable or not solvable. Okay, in actual fact, in the life, there are prompts in the computer. I don't care about those relationship problem, right, which are also sometimes unsolvable. But in actual IT, in technology, indeed, or in there are problems that are not actually solvable. Okay, but for you in this course, this is an elementary course, is a fundamental course. Most of the things that we give it to you are actually solvable. Okay, uh, that is to say that innovation that we wanted to ask from you will be too much for this particular course. But in the real life, in as you move on to higher level, you're not at 1,000 level. When you go to 6,000 level courses, which are the PhD courses, those courses are indeed possibly that you are going to encounter problems which are not solvable. Okay. Uh, Another point I wanted to make is that we are all restricted in certain sense that we know we can handle things about 4 to 7 items at a time in a way in our mind. All right, for you young, you probably can handle seven, but for me, maybe only four or at the most. If you give me more than that, I will be messed up with things. All right. So it is how do we manage the complexity when we are solving problems? So our mind are twisting and exploring, switching around, and then we always will go to the most promising one. All right. So for me, maybe I can only handle up to 4 items, 4 approaches at a time. For you, because you're young, maybe you can handle many more than that. Okay. So these are some the preview that I wanted you to bear this in mind. Okay. I'm going to talk to you about 3 parts so that how do we manage complexity. In these 3 parts, they are actually casted in some way that help me to articulate what I wanted to say. But they are by no means mutually exclusive, meaning that there are some overlapping. You will hear things over and over again because they are equally important among all these different parts. Okay, so the first thing I wanted to show you is analysis. Let me just highlight this. All right. As I said just now, this is the normal course. So the way that you're solving problem is to find out the objectives of the problem. All right. So in this course, when you are given a prompt, you basically have to find out what is the objective or what are the objectives for this problem that you're trying to solve. So you are very targeted. You are not looming in the dark. You are pretty much know what you have to find out. Of course, if the questions itself is not the objective is not clear, then there will be things that you have to do. All right. So this is usually easy if the problem is easy. Basically, if you know the objective, then it's a straightforward thing. All right. The thing about Singapore is that, or in many of the Chinese society, or at least in the Asia context, we actually do a lot of this kind of 10-year series. All right, to learn about problem solving. We are in a way trying to discover patterns. Okay. And once we know the patterns, what you're doing is a form of reusing of a code. All right, this is in the context of writing programs. Basically, if you have seen this kind of problem before, you are just reusing the code that people have or you have learned before and reproduce it. All right, so this is when the problem is easy, you can usually reach it in a step or two. Okay, so a step or two in the sense that you must have seen it before, and therefore you can immediately recall and reuse your code. Now, this is a tricky thing. Once you are entrenched into this kind of problem solvings, it can be advantageous and it can be disadvantageous because you may be, whenever there are things which are more than 2 steps, then you will have trouble. All right, so you have to bear in mind that whenever you have a problem, it's not necessarily that it can be addressed in 1 or 2 steps. It may be that you need to really do more than that to understand the problem. All right, you need to break it down the objective so that it become more than 1 or 2 steps. All right, so the thing about analysis is that you have to be able to get yourself into dividing the problem into smaller problems. In fact, wishful thinking, recursion, and so on, all these are a way of breaking the problem into smaller problems. Okay, so be careful whenever you are so into the 10-year series or kind of thing like in the A level, O level. Then don't fall into this trap that whenever there's a problem that needing 2 or more steps, you are stuck. All right, but it's just a matter of making that one extra step to be able to solve the problem. So this is particularly important. Especially, this in this society, we are so you always need to go to the past year series and solve them. But in our in now that you are in the tertiary education, we have to be even more open. And in fact, in our assessments, our midterm PE and final exam, right, it can be difficult because we have to make sure differentiate among students is our no choice. All right, so that the super good one or the average or the weak one. So usually we will have to have questions that needing you to go more than two steps. Okay, so be mindful about that, that these are things coming. All right. The next point I should make is that, right, it is not the case in real life that objectives are clearly defined. All right. And this is usually the case for researchers like myself and many other colleagues that are doing, besides teaching, we do research. And our objectives are not clear at point. And in fact, we have the liberty, we have the flexibility that we can change our objectives because a problem could be too big and we can't handle it for it that because by itself it could be unsolvable, or for it, I could be the limitation of the individual like myself. All right, then you would have to refine or make it smaller the problem, and then you solve only that smaller problem. All right, so the important thing is that you have to understand the objective. Here are some of the points that I can tell you about objective. Okay, for your case, as you going to you will see a lot of past year question. If you want to understand the objective, last week I actually talked about it as syntactic versus semantic. You can always try out small examples, and from the small examples, you actually know what is the objective of particular, the repeat pattern thing that we talk about. And you, with a small calculation, you know how to then analyze, knowing the meaning of that particular program. All right. So with simple calculations, you can then get the clue about what is actually the objective. In this case, the objective is the objective of the program. But objective of a problem, it can be stated in here also in that way. All right. And or you can somehow, for example, when you study 10-year series, all right, this could be additional steps to the question that you have studied in the 10-year series. But you can relate to it, and then you can relate to it that you can see that, oh, this is a, yeah, harder case, and maybe you can derive or you can make your current question to be towards that directions of being the problem that you have studied before. Basically, you're transforming your prompt from the current versions to a prompt that you are familiar with. All right. The next is that to understand the prompt, you also sometimes generalize the pattern. Okay. So then I will leave it to your TA afterward at 8 o'clock. He will start that to talk to you about this. Right. Once you can understand all your code, then you write your code in as I emphasize this over and over again. There are only three things that you're writing in the code. It's a step-by-step thing, or is it a repetition of things, or is it a condition of things? All right. So then we study that in recitation number one. Okay, so this is about analysis that I wanted to tell you. Basically, you have to understand the objective of the problem. If you don't have the objective of the problem, you can try out things, small versions, and try out. You can relate it to your past year learning in your 10-year series. But of course, bear in mind that you should not be afraid to make the extra step to move from a two-step solutions to a three-step solutions. Sometimes you have to make your problem towards deriving your problem towards that directions. Anyhow, these are some of the thinking that I have about how you should go ahead, go around, or go about analyzing your problem at hand. Any issue? If not, give me a check, then I can move on to the second part. Give me a check if you are okay. Okay, good. All right. So the second part is actually doing it. All right. How do you move towards your solutions? All right. In this lecture, all right, we're doing the top-down approach. All right. Wishful thinking, it's a top-down approach. You can see some of the diagram in there. All right. So to calculate this, you have these three other items to calculate. To do this problem, you have this subproblem one, subproblem two, and then this subproblem one, if you do not know how to do it, you can break it out further into smaller problem, problem three, problem, and so on. So this is a top-down approach of solving problem. Okay, but of course, once you see this kind of picture, it doesn't mean that you always need to go from the top to the bottom. It's often also in, as you will see, and I will ask these questions in our forum. They are actually this thing called bottom up, right? Basically, you know all these bits and pieces of knowledge or bit of pieces of your experiences and how you can combine them to, for example, here, combining all these things into these solutions and then combining all these solutions into these solutions. All right. So in doing from the smaller one all the way to the bigger one, this is called the bottom up. All right. And you will encounter this as in we will see this thing in here. This is the dynamic programming memorization. Memorization is a top-down approach. Dynamic programming is a bottom-up approach. Okay, so you are going to see that the contrast between these two guys. All right, now with top-down, with bottom-up, actually, this is also interesting. Wait. I will call this thing middle in. This is not a standard. This is not a standard term. Just I cooked this up at our level at this tertiary educations. We have the right to questions, the right to create new things, and in this case, bottom up, top down. It's a very distinctively from the top to the bottom or from the bottom to the top. But it doesn't stop us from thinking in the middle. All right, you may have some problem that you are kind of seeing it is in relation to the original problem. So this will be somewhere here in the middle, okay? And then you are trying to, you know that how can you solve this thing by smaller problem, and you know how to solve this thing by smaller problem. In doing so, you're doing a top in a middle in, and you're going this top down, and then you do this, all these are solved, and then you're combining them to go to the top. And this is bottom up again. So middle in is just a mind exercise. All right. In a way, we do not have to be so strict that we always go from the top to the bottom or from the bottom to the top. All right. Some of us may work better, all right, that we guess what are the things that possibly be there, and we solve them from this manner of top down, and then we're combining them from here to be bottom up. All right, so this is yet another possibility. All right, so this top down, bottom up is what we have in your lecture. All right, it's top down is a wishful thinking, which is the memorization that you will encounter in lecture 9, I think, or later, 13 or 13. And then bottom up, it's dynamic programming also in lecture 13. Anyway, I will post these questions in our forum, and then you can see by now you must have tried out quite a number of prompts. You can see for yourself which way of thinking that you are doing. And of course, recursion is going to be wishful thinking. This is going to be the top down. Okay, but anyway, for your mind exercise, you should know that all these things existed, and you should be able to play with them for whichever way that you are more comfortable. Okay, having said this, actually, I should be very careful here. All right. In many of these real situation, in especially when we are teaching, we are to be blamed. We teach you by compartmentalize our prompts. All right, because for ease of teaching, for ease of learning a particular subject, we have to cut out uh, part of the thing and teach you. All right. In actual fact, in the real world, everything is interconnected. There's no such thing as computer science prompt. Because you have to solve a problem. It's a real life problem. It's a real life problem. You have to solve it, be it computer science with IT or any other ways of other human intervention, way non-computerized manner or so on, or even with physics. All right. In actual fact, as you study more computer science, you should see that in particular in my area of computer graphics. All right, those of you who play games, you see that those realistic things that you see on the screen, actually they're coming from physics. All right, the people in the past, computer science has been over 50, 60 years, actually maybe 70 years now. You have all this knowledge in physics like recasting, radiosity, and so on. All these are coming from physics. Indeed, the latest about quantum computing, it's called quantum physics. All right. So in the real life, actually, prompts, it's just a prompt. There's no such a thing as computer science prompt. You have to see it as you go into the real life. You have to see that this it's actually you have to use whatever means that you have to do the prompt. Okay, so the next point I needed to tell you is actually doing it. How do we do it? All right. So uh, of course, our programs so far are pretty small, so you don't actually see this. But I will have to warn you that you are likely to see, you are likely to have to practice this to make your life easier. In particular, you do not want to write a big program to solve you don't want to write straightforwardly a program to solve your problem because objective itself can be broken down into smaller objectives. So, for example, in the case of your taxi fare, right? Your taxi fare, you have different cases of taxi fare, right? So, if you take the taxi for less than 1 kilometer, you pay this. If it's more than 1 kilometer but less than 10 kilometer, you pay this, and so on. So these are all the different cases. Here, of course, it's straightforwardly only three cases. Okay, if you want to ride in one go fare, you may be able to handle it. But as you will see, it's not just here, but it's a kind of habit that if you can, we always emphasize this incremental development, meaning that you don't in one go write out the whole code. You should be doing things like what I'm going to show you here. You should be doing this. All right, let me do version one, take care of the short distance. I will have this program. This program will have a part which I do not know how to calculate, but at least I test out all these guy. All right, my answer will be 333 for this case, 400 meter, 999 meter, and so on. You see that even the cases of test cases, I have to be very careful with. This is one less than 1,000, 1 kilometer. This is exactly 1 kilometer. This is 1 kilometer plus a little bit more. All right. Once we are comfortable with this, then I go to the version 2 to handle between 1 kilometer and 10 kilometer. This will be my formula. And again, you see that the case that I have to test, they're all here. All right, so I test exactly 1 kilometer plus a little bit more, and then I do this 1 kilometer plus a little bit more, well, because there's a 400 here, so I use a 400, 800, 801, and so on. So once I'm done with this, then I will do the full-fledged, the whole program, version 3. I will handle this last part. All right, so this is called the incremental development, and this is strongly encouraged. And usually, if you do this thing, in practical exam and so on, even though you may have difficulty with meeting the requirement of the whole objective as stated, if you can do incremental development, you will get partial credit for sure. All right, because this is some of the test cases you will be able to pass because these are the base cases. Okay, so don't forget this incremental development as a way of really working on your solutions. Okay, let me just all right. Of course, the way that I do it may lead to a long program, but never mind. It's once you can solve the problem, then then you come to talk about how to make it better. All right, but make it better means usually a better time or better space usage. These are the two resource parameter we always talk about. And the word that we use in the industry is called refactorization, meaning that once you know that the program is working, then you come back and rearrange things so that the program remain as short and sweet. All right, so this is usually the case. You develop it incrementally, then you refactor it until the program remains. Of course, when you refactor it, not to forget that you again have to retest most of the stuff. Okay. All right, and this point I've said it, and I will just show it to you. Basically, when we do this kind of thing, we encourage you to do incremental development because in our test cases, when we do set exam questions, we do have some of these trivial cases that you should be able to pass once you develop it in the base section. All right. So next, this is a statement I always talk about. All right. Computer science is algorithm plus data structure. As to this is functional stuff that you know how to solve. You know how to use recursions. You know how to do conditional. You know how to do the sequential. And this is the part we talk about the data. And these are the combination of things. Now, when you are the question that when we talk about CS is algorithm plus data structure, there's still a issue here that who comes first? As you will learn about when you solve a problem, the solving a problem is to get the recipe, the dish you're cooking, so you're getting the dish ready, and do you get this dish ready by knowing the recipe or by knowing the ingredients? All right. I'm going to tell you most of the time we actually needing to know the ingredient before the recipe because the ingredient generally would dictate how your recipe should work. All right, because if your ingredient is a chicken versus fish, for example, chicken is harder, fish is softer. So the algorithm, the way that you need to heat it could be different, right? Because chicken you may have to heat it longer, whereas a fish you just have to maybe 3 minutes. It's more than enough to get it cooked. All right. So in general, as you will see, the way that we solve problem always come from knowing what is the ingredient we must use. All right, and then we talk about the recipe. But this course is such that you are told about the recipe, then you told about the ingredient. One way to realize or to understand why we do this order is that the recipe usually it's much easier to teach in a way that you can get used to the time, the resources. On the other hand, the ingredient is the one that will dictate, will make a difference in the time. If you use the wrong ingredient, the time complexity could be different. All right, mainly on that. All right. So this is one way you can realize why we do it in the wrong order in a way. But bear in mind that well, at this juncture, as a new programmer for most of you, you just needed to know how to write out the recipe as to which ingredient to use. We may have dictated it for you. All right. For example, we do not want you to use list because list is so easy to manipulate. We will want you to use tuple, all right, because tuple it's immutable. We enforce that so that you see that with the enforcement, you will see that you actually pay more time. You use more time in your solutions. But subsequently, you know that, oh, actually, I could have replaced it with list. Okay, so the choice of the ingredient or the choice of the data structure are actually going to make a difference in the time more than other thing. As such, you can just follow us first and subsequently, but do bear in mind that you may have to choose the data structure to make good of certain ingredient to make good of certain dish. All right. All right. We kind of stated that data structure usually come first. This is like cooking where you need to know the ingredient first before you can do that. The next point is, all right. So this is pretty much repeating. All right. So, and I also say this, at time we fix the data structure for you to solve our problem. This is purely for the purposes of assessment. If you don't study, you're free to use any data structure. Okay. Because by the time you finish this course, when you reach this stage, you would have dictionary, tuple, list, set, to use and which is a better one. I, of course, also or not just those things because there will be a derived data structure, also tree, linked list, and so on. Okay, so just bear with us that we at time we dictate what you can use, but not in real life. Okay. Okay, the important topic here is about doing is that, all right, this is part two, doing it's that you actually spend, as you have done a few mission, you should have noticed that you spend a lot of time testing. The way that the code that you write only maybe less than 10 lines, but testing is a hell. It takes probably half a day. All right, you code it only within 5, 10 minutes or half an hour, but you are spending half a day to trying to make sense out of what you have written. And so testing, that is the part that is costing you a lot of time. All right. So smart people, a smart programmer usually do invest in testing. How do they invest in testing? They invest in writing extra codes. All right. Extra code. As you have noticed that just now when I show you this picture, all right, I actually invested in testing. I have created all these statements here. All right, these statements are not part of the solution, but I purposely put them here, all right, to see what they are. In fact, I should be able to put equal 3.0. So I should see when I run it, I should see that I should get a true, then I'm okay. Okay, I get a true here, so I know that I'm correct. So I do invest in testing. All right. So by writing things like this helps you. You don't have to go and key in your cell one by one. All right. Then you are saving time in testing. So testing is a big part of your development, and we tend want to a good programmer tend to be automating most of this stuff instead of doing it manually. All right. The next point about testing is that when you have a program which is long, tend to be branches in the program. And it's this kind of thing. It's such that you have seen what I did in our recitation number one. There are certain branch that if I didn't test it, there could be error there, but I will never be able to catch it because the program, when I try, it didn't go through that. So for testing, you are supposed to exercise. The word is exercise all the branches of your program, but you are not able to do to try all the possible uh, combinations. Okay, you have the number of combination of branches is exponential, right? To the power n. Is no way that you can have the time in the world to try all the things, but at least you should exercise every branch. All right. You will see that you have a program which go from top, go to the left, and then go to the right, go to the left, go to the left, and so on. This is branches. And all these branches, if you do all the combination, you'll be, if you have 10 branches, it will be 2 to the power of 10, which will be 1024 possibility. And there's no chance usually to try out all these branches because we don't have the time in the world to try them. So you have to be selective, but you should be mindful that selectively you should be able to exercise all the branches that you have to go through. Then your code is there's no redundant stuff in your code, and at least you know that there's no stupid error in the code that certain branch that you never go through that may have caused certain error. Okay, so these are the testing note that you have to remember. Okay, so this is so much about doing. So doing it is to know that how to do it. You have to know that there's this thing called incremental development, and there's this thing called data structure before algorithm. There's this thing called testing that you have to spend lot and lot of times. Okay, so once you can know that actually doing it means involving this kind of stuff. And I'm done with part two. Any question? If not, give me a check. We can move on to part three. Okay, I noticed that one of you or some of you may still have difficulty in viewing the recorded video. For the recorded video, as long as you log in with NUS, the, uh, the account, you should be able to view it without me granting you permission. All right. So if you are using your Gmail to log in, of course, you may not be able to see it, but you have to use the NUS account to click on the link. You should be able to see the recorded video. All right. So I do not need to grant you any permission. The permissions are all granted unless I said something wrong. Then you will not be you alone to ask for permission. There will be a few of you, then I know that I said something wrong. Otherwise, the permissions are all there. Okay, the last part of this discussion is on toolkits. Basically, we study it to collect enough toolkits. All right, the toolkits are things that we can pull out from our toolbox, and then we can use them. It's just like you study 10-year series, you pull out the thing you can use. All right, hopefully. All right, so let me just give you a few notes. Okay, here are two books that this one I actually we use it. This is Boyer. He was a professor of Stanford University, and he has passed on. All right, this is the book. It's a very famous book. You should be able to find in your library, National Library, or in the NUS library. These are talking about thinking how to solve problems. So this is one way that you can learn. The other book is also mathematical problem solving. Computer science is very much like mathematics. So the way that we solve problem, you can learn quite a lot from the way that we solve mathematical problem. So basically, the idea is that you build up, you learn something, you being taught, you learn out you collected a knowledge base, And then you have certain problem solving strategy that given to you, or you know it. There are rules of thumbs that you can use, and then you have to self-regulating, because our mind, as I say, we can keep 4 to 7 items, and you don't want to run wild. You should be able to focus and to on a particular track that you think is the most promising. You have to monitor yourself. This one nobody can help you. You have to see which is the most promising one. All right, they'll believe of what is correct, and therefore you attack in that direction. All right, and in when we doing research, this is the kind of thing that we have to live with. Basically, we only have certain gut feeling, some intuitions, feel that this could be the right way, and therefore we follow that way. Of course, if you found that there is not, there is a dead end, then you got no choice but to come back and try another branch. Okay, so and then the next point is that you actually no choice, but when you are learning a new language, you actually learn to collect some of these tricks. For example, by doing this is a common trick that if you want to get a number, rounding out a number, you just add zero point 0.5 to it, you will get a number. All right, so that it's the way the tricks that in your bag or toolbox that you have to take them, and then when time comes, then you can use it. The next one more useful is here. These are the things that by studying computer science, you will be going through some algorithmic paradigms. So these are actually things that you will see. For example, in this page, you see two of them here. All right, memorization is 10x. All right, whenever you encounter a new problem, you can always try it, see whether it works for memorization or not. Same for dynamic programming. Right? You can always try it to see whether it work or not. And besides these two, actually there are a bunch of this. I only list out some here, which I am most comfortable in a way that it's because it's a geometrical. My area is geometry. So divide and conquer, it's a top down. Marriage before conquest, plain sweep, topological sweep, and graph. This one you see in the past, many of the past year paper, they have this breadth first search and depth first search. Basically, this is nothing but more comprehensive searching, very systematically finding out things in a particular graph. A graph is collections of nodes and edges. All right, and then in AI, machine learning, optimization nowadays, you will learn about gradient descent, middle descent, multiplicative weight updates, and so on. There are many others. All right, in different area like distributed systems, there are different ways of solving problems and so on. All right, so these algorithmic paradigms are things that you study a subject in computer science. Okay, of course, this is IT. Then this is what you have to you will come to, and this set of tools, which is a long list, will come in handy when times of need. Then you can pull them out. Okay, there's one more that I should talk about. That it's this is lecture 8. In lecture 8, there is this way of solving problem. This is called computation as signal processing. All right. Basically, you know how to do something as a producer of sound. You know how to do filtering. You get to amplifying to get to the converter and then get to the consumer. So this is a pipeline. All right. This is solving a problem from producing it all the way to the listener. And this is a process of problem solving. It's a term as signal processing because you solve problem by knowing how to do this, or knowing how to do this, knowing how to do this, and then you pipe the solution from here, go into here, the solution from here, go into here, solution from here, go into here. This is basically reusing whatever you know, how to solve problem from here to so this could be a tool that you know how to use. So you take whatever this is, and using this tool, you produce this. And this is something you produce that can be used by someone else. and then you can then produce something new. So this is a step-by-step conversion from the beginning to all the end. You get to the consumer, which in this case is the solutions. All right. So this approach of solving problem, as you will see in lecture 5, on higher order function. Okay, you will see this thing very often. Okay, I'm pretty much done with the three topics that I needed to tell you. First, you think about how you analyze your problem to get to know the objective. As you will learn, and most of the time you're solving a problem with the objective coming with assumptions. I didn't talk about this today, but you will see because with assumptions, you are actually making things simpler. If you don't make any assumptions, your problem could be too big to solve. And for example, in the last week when you saw we trying to calculate the biggies, the cost, and so on, our assumption is that the input is not of any error. So our input, the what is it? The 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 size of the burger has to be between 1 to 8. All right, we never check the error for anything beyond 8. All right, so we have an assumption that the input is always correct between 1 to 8. All right, so here, as in solving problem, also the same thing. You at time you will need to do to find out what are the assumptions. Then the second point that I talked about is how to do it. And doing it, remember, very importantly, you do incremental development and also the testing part. Then the last part, I told you that as you study more, the more that you study, the more of these two kits that you're going to collect along the way. All right. So if you're okay, give me a check, then I make a conclusion. You're okay? Good. All right. So my conclusion to you are 3 points here. These are kind of equally interesting to me. Number one, problem solving can be asking when you want to solve problem, you are actually asking whether you're asking the correct questions or not. The correct questions are those correct smaller questions. For example, when you're talking about top-down approach, you are actually asking smaller problems that constitutes the bigger problem. All right. So that is asking the correct smaller problem. All right. So for example, let me just pull up this picture again. All right. For you to solve this problem, your chance of success, at time people says that a problem is half solved if you know how to ask questions. So the first point is that you are asking, you know how to ask these smaller problems, questions, then you are pretty much half done. Okay. So this is the first thing that you have to bear in mind. This is for top down as well as for bottom up. For bottom up, you actually also asking, all these kind of questions that you have, you are actually combining them to become an even bigger problem. And then slightly bigger problem, again, combining them to the original solutions. So again, this is asking the correct smaller questions. All right, middle in is also the same. Then the second point is that you are not to forget that because the way that we teach is such that we're teaching you only computer science, in this case, programming. We are compartmentalize things. So in actual fact, when you go to the real world, the problem solving is no discipline to say no. You can not supposed to be compartmentalize things. You're supposed to solve a problem as a problem in the real life. Okay, so that is the second point. The third point is that we are all different. So in the past, there was a question about do I promote top down or do I promote bottom up or do I promote anything at all? I would say that you should be acting in your own comfort, or maybe you should also acting in trying both top down, bottom up, and middle in. All right, and actually in research, I found myself to be more intuitionist. Intuitionist in this manner, you have certain intuition of why certain things should be like that. So that means that I guess how things should be like. Okay. On the other hand, I have a supervisor who is about slightly older than me only. He is a quite different kind of person. He is a very pure mathematician. So he cannot work with me. He cannot work in the way that I work as an intuitionist. He has to formulate things, making sure that all the definitions are there. Then he can then work things out. All right. So, but it doesn't mean that we cannot work together. In fact, we are actually good complement to each other. I can give ideas about how things should be done. He can go ahead and making them precise. And therefore, the two of us is actually a complement to each other. Okay, so this is what well, I wanted to conclude with for today's review. Hopefully, you learned something. And in the future, when you have problem solving, if you want to, you should revisit this to see some of these, whatever I said, actually are true. Of course, I hope that I didn't spill the bean for you that you now has less of a discovery to do for yourself. There are still a lot of things that you have to discover. Okay. Jun Jie is here. Hello.
Hello,
You have to speak louder.
can you hear me now?
Yeah, okay. I make you the host. Make host. Run co-owner to manage this meeting. And after the meeting, you can update this. Okay, change host. Okay. Then did I stop sharing?
I
Okay.
can take over when you start.
Okay. Can you
Should I just
take
start now?
over? You can take over, but you start at 8 o'clock.
All right, can.
Yeah, give them a chance for toilet break. Okay, actually, I have another 3 minutes if you want to ask question. Otherwise, I will leave. Um, just on the safe side, I may just leave my computer on in case if I quit, you are the host. All right. But I will not be around. Okay, I will just leave my computer on. Yeah. Okay, Junjie.
Yep.
Okay, good. Uh, just give them 5 minutes break, and you can start at 8 o'clock sharp. Okay. I'll see you guys next week for review number lecture 4, as well as recitation number 2. Okay, as in the same for recitation and tutorial, you're supposed to be prepared. Junjie, you can always ask question if you have gone through last year, so you know. All right, so in my review, I tend to talk all the time, but recitation, I do ask question because there are more time available. Okay, I shut turn off my video and my audio. See you guys next week. Yeah, if you have issue, just shout at me, then I will come back.
Yep. Okay, can. Okay, guys, I'll start the tutorial at 8 p.m. You all can go take a toilet break for a while.
Junjie, one thing,
Yes.
don't forget to record, right? So the recording is now on. Don't turn it off, then you will be okay.
All right. So I don't have to do anything, right? You'll just keep
Yeah, you don't
recording.
have to. You
Okay.
just share your screen. Let me see your share screen and see whether I can see it. Okay, I can.
All right.
Okay, good.
Right, hi everybody, it's 8 p.m. I'll start the tutorial. So can everybody hear me clearly? Can I get like some thumbs up? Right, okay, thanks. So a bit of introduction to me. So I'm a year 2 BZA and business analytics and business administration student. So it's a double degree. So I'm in both School of Computing and Business School. My name is Jin Xie. In my free time, I like to play electric guitar and play mahjong. So as you can see, I've gotten one times now. So this is my third time being a TA. I've taught CS1010X 1 year ago. I took 1010X 2 years ago, and I also taught 1010A last sem. So I'll be the senior TA in charge of teaching the tutorials. So your next few online tutorials, I'll be taking you, and I'll be taking one class for the in-person tutorials down the line. So without further ado, we'll start the tutorial. So question 1. So below we have a sequence of expressions. So you're basically asked to write out what will be evaluated, the output. So I'm sure all of you can simply just put them into your Python interpreter and just run them. But what you need to do for exams is to be able to derive them yourself just by looking at it. So even though you can just get the answer just by running the code, you should be able to understand how the output is generated. So let's see here. This is the main function we're looking at. First, define square x. So it takes in one input and it returns the square. Now the first few expressions are quite simple. So print square 2. 2 is passed into the function square and its output is 4. So that is passed into the function print. So print will print 4 to the terminal. Same thing goes for here. Print square 4. You get the square root of 4. You get the square of 4. Now this is more tricky. So when you see this in an exam, this is typically how I would evaluate it. I'll take a piece of paper and I'll write out. So first, we have to understand the main theory. So when we have nested parentheses and nested function calling over here, Python will read from left to right, but when it encounters like a parenthesis, it will look inwards and evaluate that first. So over here, we need to print square of square of square of 2. So first we have print. Print is given an input of this. This is the input to print, but it's not been evaluated yet. So the Python interpreter will have to evaluate this. So when it evaluates this, it'll look into square. Square is being called with this input. So then we'll have to evaluate what this evaluates to. So then we have to look inwards and we have square of 2. So square of 2 is very simple. You pass 2 to the square function, you get back 4. So that will become the input to what's on the outer layer. So I'll show you how you should be thinking through this. So print. This is basically equals to this. And this is basically equals to this. And this is what happens. So in the exams, this is what I would like to do. I'll write out starting from the first evaluation line, and I'll go step by step to get the final result. Okay, the next function is f. F takes an input x and returns x times x. So it's actually the same thing. It returns the square of the input, but it just does it a slightly different way. So print the f of 4, you get 16. Now we have a function try f that takes an input f and returns f called with the input 3. So when we see this parenthesis with 3 in it and right after a variable, we know that this variable is expected to be a function. So try f is expected to take in a function. And when it takes in a function f, it will run that function with the input 3, and then it will return this. So when you print try f, what is actually happening is that f, which is the function already defined above, is being passed into try f. So try f takes a function which it names itself f inside its local space. And whatever function has been given to try f will be called with the input 3. So over here, out here, when we pass f, which is this function, into try f, that function will be inside here and will be called with the input 3. So 3, when passed to f, returns 9, then try f returns 9. Now we have print try f equals to try f squared. So what the equals operator does is it checks for equality of value, right? So it's true because try f squared also returns 9. So what we are doing here is we are essentially print 9 equals to 9, which is true. It's true according to this equality operator. Whereas now we look at print f3 equals to square 3. So it's also true because f3 is evaluated as 9. Square 3 is also evaluated as 9. So when it comes to print f equals to square, we get false because Python will check what is the value of f. So the value of f is a function like that. And the value of square is this function. But they are not the same object. So you have to understand that the equals operator checks for equality of value, while the is operator checks for the same memory address. Now, okay, this is actually a efficiency thing that Python does, but if you learn in the idle, when ran in idle, this will actually return false because they are not the same object. Okay, never mind, we can clarify that later. So we can move on to question 2. First, use if else and define a function odd that returns true when its integer argument is an odd number and false otherwise. So questions wants us to use if else. So if x is odd, we need to return true. So the standard way to check whether something is odd is to use the modulo operator with 2. Then in this case, return true. And if not, we return false. So now without using if else, define the function new odd that does the same thing. So instead of straight up checking a condition and returning a boolean depending on whether that condition is evaluated as true, you notice that if the input x is already odd, if it satisfies this condition, this condition will be evaluated as true. So we can simply just return whatever that it is in the function. So this is what I mean. We can straight up return this expression. So what Python will do is whenever you call this function, new odd 9, so new odd 9, when it takes the input, it will check against this, it will run the expression, and this will be evaluated as either true or false. And that will straight up be piped into the return value. And that's why it's returned. So this works as normal. Right, next. Question 3, write a function that returns the number of digits in an integer. You can safely assume that the integers are non-negative and will not begin with the number 0 other than the integer 0 itself. So there are many ways to go about doing this question. And what I often see is you return length of the string version of x. So you basically convert x to a string and you just return the length of that string. Right, so there you go, that works. I'll show you some other ways to do this. Another way is you could use a loop. So let's say if x is equals to 0, return 1. Else you initialize a variable to keep track of the number of digits, start at 0. And while your input x is not 0, you keep dividing it by 10. And don't forget to increment your counter. And then return that. So this is an iterative way. Basically, you use a loop. You loop through and you divide the input by 10 while also incrementing a counter. And this loop will keep going on until you have divided your variable by so much until it becomes 0. So this is a floor division. If the current value of the variable is less than 10, it will simply be set to 0. It will not be set to a decimal because that will be a normal division. So this is integer division. Another way to do this is recursion. So you need a base, just return 1. Else, your recursive calls that return 1 plus num digits x integer divided by 10. So this will produce the same output. So there are actually many different ways you could go about this question, but these are the 3 main ways. Question 4. Define a function that takes 3 numbers as arguments and returns the sum of the squares of the 2 larger numbers. So this is a bit of a tricky question. Some people mess up this question because they don't manage to capture all the cases. So what you need to think of are all the different cases and make sure you address them. So let's start with a simple case. If A is less than or equals to B and A is less than or equals to C. This would mean that A is the smallest out of B and C, or they are all equal. But if they're all equal, it's fine. We can just return the square of any of two. So over here, if A is less than or equals to B and A is less than or equals to C, we return the sum of the squares of B and C. And this takes care of the case where all three of them are equal. So you can actually return any of the squares. Else, we consider a different case. If B was the smallest, so B is the smallest, B will be less than or equals to A, and B is less than or equals to C. In that case, we'll return A squared plus C squared. So same thing, even if A were to equals to B and equals to C, well, that will be taken care of here. But let's say over here, it's still A equals to B equals to C. This is still taken care of because A squared plus C squared is equals to the squares of the two larger numbers anyways. So these two if statements, if and else if, they take care of the case where A is the smallest and B is the smallest. So you can effectively just lump the rest of the cases into the else. This includes what the situations where C is the smallest. So you can just return the sum of the squares of the other two variables. So there are many other ways to go about this question. I'll show you some. This is a simple way. You can simply return the sum of all the squares. And then you use the min function to minus off the square of the smallest out of A, B, and C. So this will work exactly the same way as this one. So basically, you're just taking care of all the cases, all the possible cases. There are some other ways where you use lists and you can you can sort the list and you can index them by the first element and the second element and just grab those values and sum them together. But since we haven't touched on the list yet, I won't show that. All right, so the last question. So here's the logic of what we expect. So when you think about these kind of solutions, it's a good thing to draw a flow chart and plan out what the function will do, because programming is basically just logic and flow charts. So first we check, is the year divisible by 4? If not, then it's not a leap year. Definitely not a leap year. Else we keep checking because there are other cases. If the year is divisible by 4, we still have to check, is the year divisible by 100? If not, then it is a leap year. If the year is divisible by 4 and by 100, we still have to check whether the year is divisible by 400. Because if it's not divisible by 400, then it's not a leap year. If it is, then it's a leap year. So if we follow strictly this logical pathway, we can first check if the year is divisible by 4. If it is divisible by 4, we have to check all of these. So first I write what we do otherwise. If it's not a leap year, if it's not divisible by 4, we return false. Else we can keep going. I'll show you a not so elegant solution first, then I'll show you the more elegant solution. So we move on. If the year is divisible by 4 already, we have to check these conditions. So if the year is divisible by 100, then we'll have more to check. So I'll do the else first. Else, this is the part of the step. Else, it is a leap year. So we return true. So if the year is divisible by 100, we have to check these two steps. Is the year divisible by 400? If it is divisible by 400, it is a leap year. So we return true. Else, return false. Right, so you'll notice that this solution is a bit hard to read, and it's not the best way to go about writing a solution like this because you nest a lot of if-else statements. So even though we follow this logic strictly, and it will work, when we come to harder problems and more complicated problems, you should not be nesting your if-else blocks. So a better way to do this is to use a if-elif-else chain. So you notice from here, we go like this. If the year is divisible by 4, if it's not divisible, then it's not a leap year. But if it is divisible, we have to check a lot more steps. Another way you can do this is, first check this. Is the year divisible by 400? If it is, then it is a leap year. But you notice that if the year is already divisible by 400, it will definitely be divisible by 104. So we are basically checking it in the opposite direction. It's leap year. If the year is divisible by 400, then it definitely is a leap year. Else, if it is divisible by 100, then it's not. If it's not divisible by 100, then it's a leap year. So we will have to check whether it's divisible by 100. If it is, we'll have to return false. Now notice here, when we're at this step of the logic, we've already checked that the year is not divisible by 400, else it will have stopped here and returned true. So when we reach this step, year is confirmed already not divisible by 400. So when we check that year is divisible by 100, we know that we must return false because we've reached here is we already know it's not divisible by 400. Else if, now we check if the year is divisible by 4, then we return true. All right, I'll show you the others first later. Else return false. Okay, so this is the full solution. This should work the same way as the other solution. Show you the recursive version. Right, so this was a quick tutorial. The questions here are quite basic first, but we'll get into harder questions as the week progresses. So if you have any questions, you can ask me. I'll stick around for a while. But otherwise, the tutorial is complete. Yes, you may leave. No, I will not reveal my rank in bow. Nope, your attendance is handled. Bye. Here's the recursive solution. For this statement, year modulo 4 equals to 0 or year modulo 400 equals to 0. But the thing is, year modulo 4 equals to 0. If this were true, then this will always be true. So there's no reason to have to do this. It also depends. Have you addressed all the different steps? Like you need to check. You need to get the same logic as this. So you need to make sure if the year is divisible by 4, and if the year is divisible by 100, and if the year is divisible by 400, then it's a leap year. If not, you need to address these three cases. Question 4, right here.